technique, another technique of integration, the trigonometric substitution. So the trigonometric substitution is just the same with the substitution method, only that we will be using specific conditions. Okay, so okay, if we have integral containing the following, no, so say for the first one we have the square root of a squared minus x squared, and your a here is a value. Okay, so if you have a squared minus x squared, then we will be using the substitution of x, which is equals to a sine theta. Okay, and if we have positive, if we have a squared plus x squared, or a is a value, we have x is equals to, we will be using the substitution, we will let x be equals to a tangent theta. If we have the square root of x squared minus a squared, which is the opposite of this one, a squared minus x squared, then that would be secant theta. So we will be using substitution x, which is equals to a secant theta. Now, if we have this one, and if we are going to find the value of sine theta, we know that sine theta here is equals to x over a. And with the right triangle concept, we know that sine is equals to opposite over the hypotenuse. Okay, so if we have a triangle here, a right triangle, the angle here, so we have the opposite, which is x, so this one is our opposite, and we have a hypotenuse, which is a, therefore we have an adjacent of the square root of a squared minus x squared, which is this one, right? Okay, so to easily remember this one, if you have trouble remembering this one, you can use this concept. Okay, and same with tangent theta. We know that tangent theta, that is equals to x over a, and tangent is equals to the opposite over the adjacent. Therefore, if we have the opposite as x and adjacent as a, we will have a hypotenuse of x squared plus a squared, right? So this one, or that is a squared plus x squared, either way, no. And then if then we have also here, we have secant theta, which is equals to x over a. Now we know that secant is the reciprocal of cosine theta. If cosine theta is equals to adjacent over the hypotenuse, and since secant is a reciprocal of cosine, and cosine is a reciprocal of secant, therefore secant theta is equals to hypotenuse over the adjacent, which will now be, we have theta wherein your hypotenuse equals to x, and the adjacent is equals to a, therefore your opposite, what would become square root of x squared minus a squared, right, which is this one, right, which is this one. Okay, so you can use this analysis to remember the integrals containing this one, right? And aside from that, we will be using this concept or analysis in solving the integral of the given functions later. Now let us try this example. Now we have square root of 9 minus x squared, the integral of square root of 9 minus x squared over x squared dx. Now in solving this type of integrals, no, and knowing that we will be using trigonometric substitution, we will just be focusing on the part of the square root, which is square root of 9 minus x squared. And if you are going to rewrite this down, we know that this is equals to 3 squared minus x squared, which is based on our given integration. If we have the square root of a squared minus x squared, we will be using the substitution, which is x is equals to a sine theta, right? So therefore, we will let x be equal to a, our a, which is equals to 3. So we have 3 sine theta. And of course, let us not forget this part here, the dx. So to find the dx, we are just going to derive the value of x, which is the derivative of 3 sine theta, that is equals to 3 cosine theta d theta. Alright, and this x and dx here, we are going to substitute this one to our given. Right, so this will become the integral of the square root of 9 minus 3 sine theta squared divided by x squared, which is wherein our x is equals to 3 sine theta, so we have 3 sine theta squared multiplied by the dx, wherein our dx is equals to 3 cosine theta d theta. Right, and then after substituting, we will just be doing the simplification part. So we are going to simplify this one. So we have 9 minus 3 sine theta squared, that is equals to 9 sine squared theta. Same with the given below, we have 9 sine squared theta multiplied by 3 cosine theta d theta. Alright, and then we will continue to simplify this one. We all know that we can rewrite this one as 9 multiplied by 1 minus sine squared theta, right? So we omitted the constant 9, and we also have 9 sine squared theta multiplied by 3 cosine theta d theta, wherein the square root of 9, if we are going to omit or simplify square root of 9, that is equals to 3, right? So this would become 3 square root of 1 minus sine squared theta divided by 9 sine squared theta multiplied by 3 cosine theta d theta. And let us try to simplify this part here, the 1 minus sine squared theta, which is equivalent to, if you remember the trigonometric identity, okay, the Pythagorean identity, we have sine squared theta plus cosine squared theta is equals to 1. Therefore, if we have 1 minus sine squared theta, that is equal to, of course, cosine squared theta. So therefore, this 1 minus sine squared theta here is equivalent to cosine squared theta. Then going to write 3 square root of cosine squared theta divided by 9 sine squared theta multiplied by 3 cosine theta d theta. And if you're going to simplify the square root of cosine squared theta, since that is square and you have a square root and you have a square, so that would be cancelled out. So you have now equivalent of 3 cosine theta divided by 9 sine squared theta multiplied by 3 cosine theta d theta. If you are going to multiply these two, that would result to 9 cosine squared theta divided by 9 sine squared theta d theta, wherein our 9 would be cancelled out. So what's left would be the integral of cosine squared theta divided by sine squared theta d theta. Alright, so we have cosine squared theta divided by sine squared theta. So again, another review of the trigonometric substitution, or I mean identity, is sine theta over cosine theta, that is equals to tangent theta, right? And therefore, since cotangent is the reciprocal of tangent, we can say that cotangent theta is equals to cosine theta divided by sine theta. Okay, so that is just a basic trigonometric identity. Now, therefore, this with this given or function, we can rewrite this one as the cotangent squared theta d theta based on its trigo identity, right? So we have now cotangent squared theta. The function is now reduced to only cotangent squared theta. However, we cannot directly integrate cotangent squared theta, right? But again, there is another identity, Pythagorean identity, right? Wherein we have um, cotangent squared theta plus 1, that is equals to cosecant squared theta. Therefore, if we are going to find a value for cotangent squared theta, that would become cosecant squared theta minus 1. Right, so if we are going to substitute that one in our given, we have now the integral of cosecant squared theta minus 1 d theta. And then to apply integration, we are going to separate this one. We have cosecant squared theta d theta minus the integral of 1 d theta. Now, if you remember in our trigonometric integration, we have already a value or integral for cosecant squared theta, wherein the integral for cosecant squared theta d theta, that is equal to negative cotangent theta. Alright, so since we can now integrate these values, we're going to apply integration. So we have the integral of negative cosecant squared theta d theta, that is equals to, we have negative cotangent theta minus the integral of d theta, we have theta plus c. Right, so we have now these values, negative cotangent theta minus theta plus c. However, this is not yet the final answer, because again, our given is in terms of x, right? We have 9 minus x squared over x with dx. So originally we use the variable x, and we just use the trigonometric substitution to solve the integral of this given. So to have the final answer for this one, we are going to return or substitute the values, or we will return the values for this one into its original values using the variable x, right? So remember that we use the substitution, right? X is equals to 3 sine theta, right? So to find the value for cotangent theta, okay, we are going to draw a right triangle, okay, and this is your angle, and then we have, since you have x equals to 3 sine theta, therefore your sine theta is equals to x over 3. So you have x as the opposite and 3 is the hypotenuse, therefore you have an adjacent of 3 squared minus x squared, or that is equals to 9. Therefore, if we are going to find the value for cotangent theta, we need the value for the tangent theta. So since tangent theta is equals to opposite over adjacent, therefore the value for cotangent theta is the adjacent divided by the opposite, wherein we have an adjacent of square root of 3 squared minus x squared, that is 9, divided by the opposite, which is x. Therefore, the value of cotangent theta, that is negative square root of 9 minus x squared over x, minus, what is the value of our theta now? Since we have a value for sine theta, which is equals to x over 3, therefore our theta here, that would become, theta would be equal to arc sine x over 3, right? So that would be arc sine x over 3 plus c. So our final answer would be negative square root of 9 minus x squared over x minus arc sine x over 3, okay, plus c. This will be our final answer. So in answering other problems related to trigonometric substitution, so we will just follow the same pattern, and then after getting the integral given, we're going to substitute back the original given of the values.